Unit 2, Section 10.6 Worked Examples. Use the ordinary annuity formula shown to the right to determine the accumulated amount in the annuity if $60 is invested semi-annually for 25 years at 3.5% compounded semi-annual. For this problem, P will be 60, interest rate 0.035, N is 2, compounded semi-annual, and T is 25. And I went ahead and put the numbers into the formula. And I also went ahead and simplified the exponent. 2 times 25 is 50. And in the denominator, I went ahead and did the division, 0.035 divided by 2. So right now we'll focus on simplifying the numerator. And we're going to start within the parentheses. And we're going to start with the 0.035. And my calculator over here. We're going to take the 0.035 and divide by 2. Add 1. And we're going to raise it to the exponent, which is 50. We're going to subtract 1. And then we're going to multiply that by the amount we invested each period, which is $60. And then finally, we're going to divide by the denominator that we already simplified, which is 0.0175. And so the amount that we would accumulate is $4,734.13. $734.13. Becky would like to be a millionaire in 35 years. How much would she need to invest quarterly in a sinking fund paying 4% interest rate compounded quarterly to accumulate $1 million in 35 years? So the amount she wants to accumulate is $1 million. The interest rate is 0.04, 4 compounding periods a year because it's compounded quarterly, and the time is 35 years. And here's the sinking fund formula, and I went ahead and entered the numbers in down below, and I went ahead and simplified the numerator. 1 million times 0.04 divided by 4 gives me 10,000, and in the denominator I simplified the exponent. So we're going to focus on simplifying the denominator first. And so we're going to start in the denominator, and we've got the 0.04 divided by 4. And then we're going to add 1. And then we're going to raise it to the exponent, which was 140. And then we subtract 1. Now, as I showed in the earlier videos, I'm going to go ahead and put this into memory because I need to divide this number into my numerator. So rather than writing it down on a piece of paper, my calculator here has a memory, so I'm going to go memory plus. And then I'm going to go and I'm going to put my numerator in, which is $10,000. And I'm going to divide by, and I'm going to recall that number from memory. And so the amount that she needs to put in each quarter is $3,303. Now it rounds to 49, but we want to round up because we want to make sure at the end of the 35 years she indeed has that amount. So for this type of a problem, you're always going to round up. So the amount that would need to be invested each quarter is $3,303.50. And again, let me pull that calculator up and just make sure that that's clear why I said that. So in the calculator, when we did the calculations, we actually came up with a calculated value of 3303.49, but you're always going to round up, so it rounds up to 0.5.